formula, it is on page 431. And what this formula is going to look at is how much money you would have in an investment if you decided right now you wanted to save up for something. Some of you have a job, you're making money every month, and of the money that you make every month, you decide, I'd like to put $100 or $200 away into an investment every month and see how much my money grows. This formula will find the future value of that investment. R is what you're putting away every month. I is your interest rate per compounding period. So it's really the interest rate divided by n. And n is the number of compounding periods. Again, this formula would be given to you. It's a little bit more involved than the formula that we looked at yesterday. So we're going to see how we could solve this. So determine how many monthly payments $200 would have to be made into an account that pays 6% annual interest compounded monthly. So we want the future value. I'll write out the formula again. Minus 1. So there's our formula again. So we want our future value to be $100,000. We're only putting $200 away a month. The interest rate is 6%, so as a decimal, compounded monthly. So the I is your interest rate per compounding period divided by I again. So the start is just, can we put all of the stuff into the formula? And now we want to solve for n. And n is an exponent in a power. So what makes this question just a little bit longer, but not necessarily harder, is that you have to, first of all, before we take the log of both sides, our life is going to be a lot easier if we can get that power by itself. So now it's just some simple algebra first to get that purple box by itself. First thing I would look at is, oh, I'm dividing by something. What's the opposite of dividing? I would multiply both sides by 0.06 over 12. That would simplify this. And these are, of course, calculator questions. So if I would take 0.06 divided by 12 and multiply it by 100,000, I get 500. Again, I am trying to get this by itself. I'm closer now. What should I do next? That's an opposite operation. Well, I have this 200 out in front. I could divide both sides by 200. $500 divided by 200 is 2.5. And now that I've got that 200 out, do you see that these big square brackets are no longer necessary? They just be holding everything on the side. They're not actually doing anything anymore, so I could just write the 1 plus 0.06 divided by 12 n minus 1. I'm so close to getting my power by itself. I just need to add 1 to both sides. final exam, they would give you a half a mark for plugging everything into the formula in the correct spot. They might give you a half a mark for all of this work in getting this by itself, and they might not. Because technically, this work of rearranging an equation, you learned in grade 9. So on the grade 12 exam, they like to give you marks for grade 12 concepts. When you do work of stuff that you're supposed to know already, they're like, well, you knew that already. So there might not be any marks assigned for that. Sometimes they would say, okay, that's a lot of algebra that we just did. Maybe I'd give you half a mark. And now that we've got our power by itself, we can take the log of both sides. And this step is sometimes given a full mark, just for writing the word log in front. And then saying, hey, I have a log law, when that's the exponent of the entire thing, I can bring it out in front. This step is given another full mark. So once you get to the part where you get to use your logs and your log laws, that's where the marks come in the question. And now we finally got n out of the exponent. It's very easy to get that n by itself. Divide both sides. Oops. Very easy. Don't make a mistake. We need to get to n by itself, so we need to divide by that log of 1 plus 0.06 divided by 12. And we can go to our calculator. Log of 3.5 divided by log of 1 plus 0.06 divided by 12. 251.178. Question says, determine how many would have to be made for the future value to be 100,000. Now this is an interesting question, because if we round to the nearest payment, we would get 251. But 251 wouldn't be enough payments to get to $100,000. So sometimes questions like this the rounding is different. So this one I'd have to, if I want to get 100,000, 251 isn't enough. We can only make full payments, so you'd have to go to your 252nd payment. Now, on your graphing calculator, there is a program. It's probably the most, once you get out of high school, as far as programs on your graphing calculator go, I would say it is the most useful. I've used it a ton when I'm like buying a car or buying a house or trying to figure out how much my money is going to be worth. These are questions you would like to know because maybe you're planning to buy something or maybe you're just trying to save money. My goal for today's class is to save you tens and thousands of dollars over your lifetime. And it's about knowing how exponents and logarithms work. So first of all, I'm going to show you the program. So it's under the apps button and finance. And you can find programs like this on the internet. They're like time value money programs. And it has a bunch of things listed. N is the number of payments. So that's what we're going to solve. I'm going to leave that number in there. In this case, our interest rate was 6%. And in the program, you don't put it in as a decimal. We have a present value and a future value. For this one, we started with $0. and we put payments of $200 away each month. Now, the program needs some way to determine whether you are getting money or putting money away, investing or paying something. So anytime in this program, you would be like, I need to take money out of my pocket and put it somewhere else, either pay someone or deposit it in the bank. In this program, we put that in as a negative. So since we're putting away $200 every month, that's going to go in as a negative. In the future, we want the bank to give us back $100,000. Since they're giving that money back to us, that would be very exciting to try to put $100,000 back into your pocket. You'd have to get some pretty big pockets, but it'd be pretty fun to try. I would like to try that one day. That's going to be positive. Payments per year are 12. Compound per year is also 12. So we can put all of the information that we put into the formula into this program. The key thing in this program is anytime you're putting money away, you use a negative. Anytime you're getting something or getting money, you put a positive. Then we can go up to the end, and above your enter button is a solve button. So we push alpha and then solve, and we get the exact same number right away without having to do all the algebra. Okay? I mean, the algebra is great, but I'm going to tell you in your real life when you're trying to figure out, oh, how much I want to, I need $100,000. What would you be saving up? Maybe you're buying a house. What's the problem with only putting $200 a month away if you need a $100,000 down payment for a house? 251 divided by 12? Uh-oh, that's 20 years. This isn't going very fast for you. If you wanted to buy a house, you're like, oh, I'll do $200 a month. It's like, yeah, well, you can buy a house in 20 years. That's not quick enough. So then the nice thing about this program is we can see, well, what would happen if I put $500 away a month? I can just quickly do a change like that. Right now it's only 10 years to get to that same amount. So you're like, okay, maybe you want to start planning already. I want to be able to buy a house before I'm 30. If I start saving $500 a month now, put that aside, I'll have enough for a down payment. And that would be exciting. Okay, so questions to circle for number 1 are 3 and 6.